Hey everyone, welcome back to another video. So in today's video, we'll be looking at implementing a machine learning algorithm, namely support vector machine, on the Amazon Alexa dataset available on Kaggle. The dataset consists of nearly 3000 customer reviews from Amazon on various products. If you want to know how to implement a neural network for sentiment analysis classification on this dataset, you can check out my video on this topic. The link to the dataset and other links mentioned in this video can be found in the description box below. If you're new to this channel and like my content, please hit the like button and smash the subscribe button and turn on bell notification to stay updated each time I upload a new video. Stay tuned. So first let's import the required libraries. So here we are importing Pandas for basic data operations. We are importing matplotlib and cbond for data visualization. Then we are importing style to set the style for the plots, and here we are using the style as ggplot. Then we are importing re for using the regex function. Then we are importing word tokenize to perform tokenization. Then we are importing potStemmer to perform stemming. Then we are importing stop words to remove all the stop words, and then we are setting the stop words as English. Then we are importing word cloud to plot the word cloud. Then we are importing tf-idf vectorizer to vectorize the data. And finally, we are importing train test split to perform train test split on the data. Now that we have imported the libraries, let's read the data from the file. Note that the data file is in a TSV file format. So to read the data file, we need to specify the file separator. Now that we have loaded the file, let's visualize the initial data using the head function. Now we have an idea of the dataset. Let's use the info method to gain some more insights about the dataset. So this gives us an idea about the number of columns, the rows, the data types of the different entries. Let's analyze each of these columns further. Let's start with the rating column. This indicates the different ratings given by the customers. Let's use a count plot to see the distribution of the different ratings. So now we have a count plot of the different ratings. Now instead of using a count plot, we can also use the value counts method to get a count of the different ratings. Great. Now we have a count of the different ratings in our data. How about we visualize the percentage contribution of these ratings using a pie chart? Let's do that next. Now here for this project, I am going to create a simple pie chart. If you want to know how to take your pie chart from this to this, make sure to check out my pie chart tutorial video. I'll add links to it in the description down below. So let's specify a size for the pie chart. Now let's specify the different tags in our pie chart. Then let's plot the pie chart. Then let's add a heading to it. So now we have a visual representation of the distribution of the ratings in our dataset. Let's now analyze the next column, variations. The variations column in this dataset is used to indicate the different product variations being sold on Amazon on which the customers have commented. Just like we did for the ratings column, we can use a count plot to see the distribution of the different products. Here I'm going to be plotting the variations on the y-axis to make it a bit more appealing. So there we have a count plot of the different product variations. Now just as we did before, we can use a value count to get a count of the different product variations. Now we have an actual number of how many of these products are there in our dataset. Let's now analyze the feedback column. This is our target column and is used to indicate if the comments given by the users are positive or negative. 1 is used to indicate positive comment and 0 is used to indicate a negative comment. So let's use a count plot as before. Instead of using a count plot, we can also use a pie chart to see the distribution of the different sentiments. Now we have a pie chart showing the different user sentiments. Notice the similarity with the ratings pie chart? What do you infer? Let me know in the comment section below. Now since we have done some initial analysis on our data, let's proceed to process the text data to make it ready for model building. So first let's analyze some of the user reviews. Here I am printing the first 5 user reviews along with their feedback. Now that we have an idea of the data that we are dealing with, let's proceed to process this data. Data processing is done to make the data into a usable format. There are different steps involved to make the data into a usable format. You can do them individually on the text data, or what I'm going to do here is to create a function that does all of the text processing and then I'm going to pass my data into it. So let's define a function to do the different text processing. So here we are performing lowercase conversion, then we are removing any URLs, then we are removing the punctuations, then we are performing tokenization and stop word removal, and finally we are returning the join text. Now let's apply this pre-processing function on the text data. Let's also perform stemming on the data. Here for this project, I'm going to use Porter stemmer. You can also use any other type of stemmer such as Lancaster stemmer or Snowball stemmer or even lemmatization instead of stemming. The Python codes to perform those are there in my tutorial videos. So let's now perform stemming. Now let's apply the stemming to the process data. Now let's analyze the same text as before to see the process data. So here you can see the effect of the pre-processing function. Now that we have processed the text data, let's visualize the positive and negative data using a word cloud. To do this, I'm going to separate the positive and negative data. So here we have the positive data separated. Now let's create a word cloud to visualize this positive review. So here we are pulling text data from the positive reviews. Then we are setting a figure size. Then we are generating the word cloud, and then finally we are adding a heading to the word cloud. Now if you want more detailed explanation of word cloud, or if you want to take your word clouds to the next level, you can check out my video on this topic as well. I'll add all the links in the description down below. Now similarly, let's do it for the negative reviews as well. So first we'll separate the negative reviews. So there we have a word cloud for the negative reviews as well. Let's now proceed to build the LSTM model. So first let's import the various libraries to build the LSTM model. Now we are importing sequential, as sequential helps to build the neural network model layer by layer. We are importing tokenizer to vectorize the text corpus. We are importing path sequences, as path sequences are used to make sure all the sequences in the list has the same length. Then finally, we are importing the different layers to create the different layers in our LSTM model. Now that we have loaded the libraries, let's tokenize the X data. So let's load the tokenizer. So here we are loading the tokenizer and setting the number of words as 500. This basically indicates a maximum number of words to be kept. Fit on text is done to update the internal vocabulary based on the list of texts. Now we need to transform each text in the text to a sequence of integers. To do this, we can use the text to sequence method. Now let's apply padding on the X data and then print the X data. Let's see the shape of the X data using the shape method. Now let's split the data into training and testing set. Now let's put in the size of the training and testing data. Now let's create our LSTM model. So first I'm loading the sequential layer, and this is going to be a first model configuration. Next let's add the embedding layer. The embedding layer takes in 3 arguments: the input dimension, the output dimension, and the input length. Here for the input dimension, I'm giving the same dimension as the number of words. Next let's add a dropout layer. Dropout layers are used to help prevent overfitting. Next, let's add an LSTM layer. Then let's add a dense layer with a sigmoid activation function. Finally, let's add the loss function, the optimizer, and the metrics used. Then let's print the model summary. Feel free to play around with the model configuration to see which configuration gives the best model accuracy. Now let's fit the X-train and Y-train on the model and train the model. Here I am setting the epochs as 10 and batch size as 32. You can also experiment with this to see if there is any change in the model performance. Now let's evaluate the model on the test data. So this model gives an accuracy of 92.06%. Finally, let's plot the training curve for the model loss and accuracy. So now we have the plot for the model loss and the model accuracy. Let's experiment with one more model configuration. So for the second model configuration, I am removing the dropout layer, and then I am reducing the number of nodes for the LSTM layer, and then let's print the model summary. Then let's fit the data on the model and run it. See, that's why I told you need to play with the model parameters to see which model configuration gives the best model performance. Make sure to follow me on my social media handles for more updates. I'll be uploading the code on GitHub to make it easier for you to refer. That brings us to the end of this video. Please do leave a like and subscribe to this channel if you found this video useful. Thanks for watching and see you in the next video.